Hi, everyone. Welcome to ECE220. For those of you who are watching at home, welcome to the online space. We are here today on Tuesday at 12 o'clock, working with a whole bunch of students that have joined me today, ready to embark upon science and early childhood. So hopefully everyone's positive. Chatting to people before I started recording, there is a bit of positivity around start of trimester, excitement, enjoyment, and all that kind of stuff, which is super awesome because you will need that as we go through the unit. Just going to do a bit of housekeeping to begin with about the unit. We're going to go through floating and sinking today, which is excellent. And then we're going to go through some experiments. And then I'm going to talk a bit about science concepts later on, and we'll start to go through assessment 1A and 1B to get you guys grounded as we begin. So some of our objectives today, we are going to learn about floating and sinking through some experimentation. If you haven't had a chance to get the materials, I presume Jaya, who's in the car, doesn't have a tub of things that she's going to float and sink. That's fine, as long as you have a bit of a practice later down the track. We're going to be looking at ways that we can represent phenomena in different kind of ways. We're going to look at teachable moments. We're going to focus on what a science concept is, which is one of the key things that you need to know for this unit for every assignment, as well as to explore what some of those science concepts are of floating and sinking. Right, so I am the unit chair for this unit. That is my email address, george.aranda@deakin.edu.au. And so, yeah, these are the materials that you will need. You will need that textbook there. I will show you later on how to find the textbook if you've not had a chance to locate it. I just want to make sure it's available at the library. You don't have to pay for it. You don't have to subscribe to anything, but I'll show you how to get there, not a problem. And this page, this website here at the bottom is something that I will show you as well. Really critically important that you look at the textbook. You need to read the textbook as well as go through that early years website later down the track. If you're following along at home, the online tutor is Dr. Xiuqin Niu, as well as if you're at Burwood, it is Abigail Henderson who'll be running the face-to-face seminars. As we are online together, I really think it's important to make sure you guys have a collaborative experience. For those of you who have come, I do expect you guys to have your cameras on as much as you can. You can stay muted, that's perfectly fine. But it's also good to have a bit of a conversation if you're confident enough and your microphone's working to join us in a conversation. A bit of back and fro is always a suitable thing. I do want you to be engaged with the seminar. I don't really want to see you munching away on a sandwich as we're having a conversation or anything like that. And make sure you try and bring some of the required materials as we come back each week. We'll be having different experiences. And as much as you can, bring the materials with you, because there's nothing better than having a hands-on experience. Because you know, when we're working with children in early childhood, having an experience with the materials ahead of time will put you in much better stead when you're working with your students. Some other things, seminars are really dedicated to hands-on experiences. Questions related to assessments should be put in the discussion space. Now, there are 300 students in this unit. So if you have a question, I've got Tess there. If she has a question, it's going to be the same question that Holly has, that Connie has. So if I can get Tess to put that question into the discussion space, I'll show you where that is if you don't know where it is. It's better, instead of me answering 300 questions that are the same, answering once, and that everyone can share from that kind of learning process. I'll also be going through Q&A sessions. That one of them I'm going to record later on today for assignment 1A and 1B. But of course, if you've got questions that you don't want to put online because, you know, they're of a personal kind of nature, please feel free to email me. Okay. So myself and Taylor this year is going to help me out with the discussion space to answer any questions that you might have about the assessment tasks. How does everyone feel about that? Okay. Thumbs up. Hopefully, you know, it'll all start to make sense. If it's all confusing and I'm using a lot of unusual terms, that's fine. You'll get the hang of it. Not a problem at all. Right, I'm going to give you a couple of minutes now. So what we're going to do is we're going to be doing floating and sinking in part 1A. So you need to have a transparent tub of water. I'd say something like this that we're going to do, something relatively big. Would be great if you can get a bunch of materials that you can put in the water. Make sure they're different materials. So I've got a little tub of materials here. So some things are plastic, some things are wood, some things are metal. I also have a little ball of Play-Doh or plasticine, so make sure you bring that. Don't need the foil. If you don't have it, that's fine. Don't panic. But I'm just going to give you a couple of minutes to find some materials and then we'll come back together. Is everyone okay with that? If you've already got your materials and you're good to go, have a quick ciggy or something like that if you want to. Not promoting smoking or anything like that. But take a moment and I'm just going to pause the recording for a moment and we shall come back in a couple of minutes. Okay, so everyone can still see the slide on my screen? Yep, excellent. Thank you very much. Okay, so in part 1A, we are going to be doing floating and sinking today, very hands-on. Seminar 1B, I have a recording that's put online for you, and I'll show you where that is. Basically, we're trying to give you the best of both worlds. So some hands-on experiences with me, and part 1B will be a recording I've done in a previous year that will take you through the experiments you can do with air and flight. So I suggest when you have the chance, you watch it and you try and do some of the activities that are done in the air and flight session. Okay, just means you have a bit more flexibility being face-to-face with me in a synchronous kind of way, as well as being able to go through recordings in your own time. Okay, so what is floating? Floating is a really important kind of activity. So you guys can see the drawings on the screen. There's a whole range of different things. So we've got an apple, we've got stones dropped into water, a person wearing a life jacket, and all the rest of them. Which of these objects do you think is floating? Which of them is not floating? Why do you think it is not floating? Okay, we're going to go through one of them. Okay, so what about, let's try one that's a little harder. I presume everyone can see that apple is floating. I think we all agree the apple's floating in that one. Excellent. Okay, so what about, let's see, the submarine. Is the submarine floating? And if yes, why? And if no, why? What does floating mean? What do we think? Pop it in the chat window. Jaya says, no, it's not floating. Jaya, do you want to elaborate for me? You can put your mic on. You can type it in the chat window. You're going to be educators. I suggest you project your voice as you can. It is not sinking to the bottom. Okay, so something not sinking means what? What does it mean when something's not sinking? I feel I should have some thinking music. Anyone? What do we got?
I was going to say the submarine is floating because it's buoyant and it's suspended.
Ah, it's buoyant. Okay, so buoyant means it can float. Is that what buoyant means, do we think? Yep. And it's suspended. Was that the term you used, Holly?
Yeah, so it's not actually, it's just sitting there floating. It's floating. It's not actually going, it's not sitting on the bottom of anything.
Okay, it's not sunk would be the term.
Yeah.
If it was at the bottom, it would have sunk. Okay.
Is it still classed as floating if they're using propellers to keep it up?
That's a good question. That is something that we are going to investigate. So what I'm going to do now is I'm going to pop you into a chat room for, we'll say 5 minutes. And I want you to discuss with the people in your group, go through the entire list of things that you think are floating and you think are sinking, and you have to justify why. I think it's floating because. I think it's not floating because. And those kind of questions are going to come up. The great question from Jordan. If it's got a propeller, does it mean it's floating or sinking? Is everyone okay with that? 5 minutes. Make sure, what I want you to do now is if you're at a computer, take a screen grab of the screen there, because when I pop you into groups, that image is going to disappear. Okay, so make sure everyone does that. And I'm going to give you 5 minutes. I'm going to pop you into, how many people do we have today? Participants, 22. So I'm going to pop you into groups of about 5, so you won't be alone. 4 breakout rooms. I'm going to give you 5 minutes to have a conversation, go through all 12 of those items and see what you think. And then we'll come back and have a discussion. Okay. All right. I'll see you in a couple of minutes, 5 minutes. Open all rooms. You should get an invitation to go to a room. I'll see you shortly. All right. Who's going to talk to me about what were the ones? All right. Let's go through them. Apple. Is that floating or sinking?
Float.
Floating. That should be pretty easy. I'm pretty sure everyone got that one. What about stones dropped in water? Floating or sinking?
Sinking.
Sinking. Okay, so it's in the process of going down. Person wearing a life jacket. What do we think?
Right. Would be floating. The life jacket is floating, but the person is sinking, maybe?
It's sinking. I like the breaking apart of the different materials. I do like that.
Or the person might sink if it wasn't wearing the life jacket.
I like these
conditions. And wasn't using force to keep themselves up.
Forces have come into it. Excellent. Spiders standing on the surface of water. What do we think? Floating or sinking?
Floating. Floating.
Floating. Okay.
Floating.
So which one was a controversial one in your group? So
Bubble.
which one?
The bubble is rising to the surface.
Right. Okay. So what was contentious about that one?
Well, we were just a bit confused because it said pick the object that's floating. We were like, are the bubbles floating or are they actually just rising to the surface?
We got our new word rising. We have sinking. We have floating, rising to the surface. That's a good one. I like that one. That breaks apart the bottle as opposed to the bubbles themselves, which is fine. All right. What else? What was another controversial one?
We were talking in terms of the submarine,
Mhm.
whether like the definition of floating is whether it's still floating if it's submerged but has control, as opposed to is floating something that has to occur on the surface.
Right. Okay.
Mhm.
That's a good point. So we don't know if the submarine's moving. In this case, I think Jordan was asking if the propeller's moving. Does that change it? If it's just stationary underwater, is that floating? What do people think? Is that floating or not floating? If it's just stationary underwater?
Floating.
Thinking then, yeah.
Yeah, it could be.
I think the submarine is giving force to the sinking position.
Yeah.
Maybe
So,
the physical, there may be any transformation.
okay, just a little
Yeah.
breaking up on the microphone there. Nivathana, thank you.
Yeah.
Okay. What about what one more? What about the yacht in trouble? What is that one?
So that's kind of sinking.
That's kind of sinking. Yeah. The yacht's in trouble. It's probably going down in that particular way. So one of the things I hoped, so as you can see, this is a task or a type of tool you can use with students to generate a conversation. Okay. As you saw, I didn't come over the top and just say, this is what floating in is, and this is what sinking is. I wanted you to struggle with it. Because as you said, as you indicated, some of these are ambiguous. What do you mean, George? What, a stone skimming on the water is that's not floating. That's just bouncing, isn't it? It's not really floating. So what is the general definition, do we think, of floating? If before you came into class today, what would you have said floating is?
Something
on top
not
of the
moving
water.
in the
Yeah.
water.
Something's not moving. What was the other one? I think it was Holly. On top of the water. Right. And that's what most adults will say, that floating is something at the top of the water. And that's the experience that we have, isn't it? And that's the experience of our EC kids have. Everything in the bath, if it's on top of the water, my rubber ducky, it's floating. So what I want you to do now, so I've got this whiteboard here, and I'm going to say, we have our water here, and we have our object here. What are the forces playing on the objects that are in those pictures? If something's going down, why is it going down? What's the magic word? Gravity. Yep. So we have an arrow that comes down to indicate the pull of gravity on an object that's in water or on land for that matter. But what if it's, so that's our definition. So what's making it not sink?
The size?
Size could be part of it. What else?
The weight of an object.
Weight.
The weight of the weight of the object would be the gravity, wouldn't it? It would be, so it's something, obviously, if something's not moving, and I think that's what we're moving towards, the definition of floating. So the submarine is floating, and I think it's because it's not moving up and it's not moving down. So when something's going up, it's rising, isn't it?
Mhm.
And something's on its way down, it's sinking, isn't it? So
Mhm.
there's got to be a force that stops, that pushes up. So when we put something in water, sorry.
Air?
The upward push of
Air
the
in there,
water,
oxygen.
Well, I love the thinking, Veronica. I think Tess, what were you saying?
the upward push of the water underneath.
Upward push of the water. Has anyone tried to put a basketball in water or a
Yeah.
ball? What does it keep trying to do?
Bounce out.
It pushes up, doesn't it?
Yeah.
So the water, it is filled with air, but the water is pushing it out of the way. So I want you to draw something like that. Okay, just have a quick go. Just quick 20 seconds. I don't need any great artistry. Don't need shading or perspective or anything like that. Okay. So if I wanted to be more precise, that's what's happening here. So what we have is the pull of gravity, which is our arrow that comes down. And then we have the push of the water, which is the arrow going up. So if we're thinking of something that's floating, the forces are equal, aren't they? Okay, equally, if I wanted to, I could draw another picture, and I want you to do this. We have our sea, and in this case, we have our submarine. Not a great drawing by George there, But then again, it's floating. So I need forces of equal strength. So the weight of gravity is pulling it down, but the push of the water is keeping it in the same spot, isn't it?
Mm.
So hopefully you can do something like that. Okay. And so one of the things I'm going to emphasize in this unit is that I need you to do some drawing. Okay. It's called a representation of ideas. So one of the difficulties with forces and with air and flight is that we can't see these forces, can we? We can't see the pull of gravity. We can't see the push of the water. And so when we were working with our kids, we might get them to draw what their understanding is. We know in early childhood, our students may not yet have the vocabulary to talk about it. Holly used the word buoyancy before. You may or may not have a little person that says the word buoyancy. And even if they do say the word buoyancy, I would ask you to take, what do you mean by buoyancy? Okay. Little children can say words like photosynthesis, and they know what DNA is. They can say DNA, but it doesn't mean they know what it means. Okay. They know it has to look, why I look like mum or dad is what DNA is to little kids. Okay. So always make sure you have the capacity to question them about those kind of things. And using a representation like this, whether it's a drawing that you do, or whether it's a video that you show, or a story that you read, or a song that you make, and children will also use gesture in their discussion with you, won't they? So when I'm talking about, well, how did the leaf fall? They might not have the word for flutter kind of thing, but the leaf went like this on the way down. They can tell you that much. And that's a type of data you're going to be collecting in your assignments as we go along. Okay. Everyone okay with that? I've not destroyed anyone's world by redefining what floating is and sinking is. So make sure when we're going through our units, you've got a good idea of the terms and how you're going to use them. All right, we're going to move on at this point. But you could see how having something like this with your kids will be useful to generate a conversation about what they think about certain things as we go through. All right. So we have this lovely water garden here. We have plants that are floating at the surface. It has to do with the shape and the weight of the object. And that's something that we're going to explore today in our class. Now, one of the things you're going to do in your sessions is something called a predict, observe, explain. Have people heard of predict, observe, explain before? Mm-hmm. Right. So this is what we're going to do today. So we're going to have a prediction about what's going to happen. We've got to know why. We're going to test and observe that, and then we're going to explain what happened, relating it back to the evidence that we've got. So in your pieces of paper that you have in front of you, what I want you to do is go horizontal, and I want you to have a column for the names of your objects. So you've got rubber ducky, you've got piece of wood, whatever you got there. You're going to have floating, you're going to have an F, and sinking, and a little spot where you can take some notes. Okay, so I think you can see where we're going with this, is that we're going to make a prediction about the objects that we have. I'm sure, hopefully you've got, more than half a dozen, maybe about 10 objects that you can take with you. So we have a column for name of the object, whether it floats, whether it sinks, and all I want you to do is tick whether you think it's going to float, tick whether you think it's going to sink. Okay, so I've got all these objects. I've got about 10 objects in front of me. Don't go crazy. I don't need you to do 20 or 50 objects. Just want you to pick ones that are different. If you've got 10 things that are plastic, that's a problem. Okay. So if I've got this ping pong ball here, I'm going to make a prediction about whether it's going to float or sink. And in that last column where you write a note, I want you to put a reason why you think it's going to float. Make a prediction. Have a reason why you think it's going to float. I think this ping pong ball is going to float because I know it's got air in it, and I know it's really light for its size. Okay. Then I've got this cork. I predict that this cork is going to float, mainly because I know it's made of wood. It's really light for its size, and I'm pretty sure there's air inside it. Okay. So I'm going to give you 2 minutes now. I want you to go through every object that you've got. If you've got more than 10, just stick to 10. And you're going to tell me if tick, float, or sink. And then you're going to write a note as to why. Everyone understand? Capiche? Entiende? We're all good?
Yep.
All right, 2 minutes. Quickly do that. I'll put some elevator music on. Do, 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 do. All right, I'm going to just change the microphone now, and so no one gets sick with me moving camera. I'll just pause you for a sec. All right, you guys can see that okay? All right, so everyone's made a prediction, made their predictions. Can I get a thumbs up? If you don't have your camera on, give me a thumbs up in the chat, or next to your name, so I can see you're all good. Thanks, guys. Katie, Amy, Jess. Okay. Thanks, guys. All right, I'm going to keep going on. You can still make predictions as we go through. Ooh. I'm working with 3 screens here. All right, so now get your materials ready. Make sure you have them in front of you. I'm just going to turn off my share so you can see me a bit better. All right, everyone can see that here. Right. So one of the things that we're going to do is I'm just going to go through how we do this testing. So when we're working with anything to do with science, people know what a fair test is. And we know that our young kids will really know what a fair test is. If you've ever shared M&Ms with little kids, they know what fair means, right? So when I'm testing this, am I going to drop it from up here? No, thank you, Alicia, for the head shaking. I love it. If I drop it from, I'm not going to do it. Why? Alicia, tell me why I don't drop it from up here.
Because you're putting force into it.
Yeah, I'm adding an extra variable, and that's
Yeah.
falling to the actual water. I've got this piece of plasticine, this Play-Doh. If I do that, that's going to change things. So I don't drop things from up here. I don't drop things from up here. And your kids will know that if I'm doing a fair test, they both have to be dropped from the surface of the water, or as close as we can. So I'm pretty sure everyone knows this is going to float. Incredible. Who would have thought? All right. Hopefully that's not a surprise to you. Then we'll grab something else. All right. I've got this little rubber stopper. This is a little harder. So this is a rubber stopper. It's actually quite hard and dense. This is the kind of thing you'd put into a test tube. Stop it if you remember your science days. So what do we think? Who thinks that this rubber stopper, this hard rubber stopper, is going to float or sink? Give me a thumbs up if you think it's going to float, thumbs down if you think it's going to sink. Or a flat one if you're not sure. Sinking. All right, let's see. I'm going to put on the surface of the water. 1, 2, 3. Sunk like a stone. Okay. Now, so what I want you to do is I want you to do this. I'm going to give you 5 minutes to test your objects, and I want you to make observations as you go. Really important. So I've got this one. This is a bit different. Do people know what this is? This is a practice golf ball. So if you're learning how to play golf, you'd use this on your golf swing because it only goes 1 meter and you don't have to chase your golf ball the whole time. And I've just, spoiler alert, aha, you didn't see it. Excellent. All right. So what do we think is going to happen? This has got air is going to flow through it. What do people think is going to happen with this one?
Gonna fill up with water and sink.
Fill up with water and sink, Holly? Anyone else?
Sink.
Sink? Okay, let's give it a go. All right. 1, 2, 3. Sinking, but it doesn't sink to the bottom. It's a really important thing there. It's not at the bottom, it's just above it.
Yeah, it's floating.
Why do we think? Why didn't it just go right to the bottom? Jay, you got your microphone on?
Got air in there.
Yeah, it doesn't quite go underwater the whole way. We could test that. Well, what happens if I pushed it all the way under the water, like I'm doing now? All the way. Does it stay at the bottom? It'll come back to the top. And we could argue that maybe there's a little bit of air bubble that's caught in there that we can't push out. Okay. So when you do these things, I want you to make an observation. Don't just say whether it floats or sinks. Tell me how it floats or sinks. Heavy things will just go thunk right to the bottom. Light things might just drift down like that. Things like this might need a bit of testing. Well, what can I do? I can push it under. Does that get the air bubbles out? Okay. Because when you do this with your kids, you're going to ask them, well, what can you observe? What does it mean if some bubbles come out? That was interesting. Karen, why do you think? So we can question them about what they think. It's not just whether it floats or sinks, it's how it floats or sinks and what that tells us about the object. Okay, I'm going to give you a couple of minutes, test all your objects, write down your observations in that notes section there, and we'll have a quick discussion about it in a couple of minutes. Okay, everyone good? Thumbs up? Excellent. All right, I'll give you a couple of minutes to do that. Right, so I'm just also going to share my screen again. All right, so you guys can see that again. Get your materials ready, is that right? Right, as you're going through, I want you to think about when you made your predictions to begin with. Is writing the best way to make a prediction? Remember, we're working with early childhood children here. Will always getting them to write a verbal response be the best way? Would maybe getting them to do a drawing be a better way that we could get them to do it? Okay. Or are we going to rely on a verbal response? I mean, as you're collecting data in your assessment tasks, you will need to scribe the kinds of things your students say and use a quote as your evidence that you're going to be using in your assessment tasks. All right, so keep that in mind. We know that our children don't have the biggest vocabulary yet. And so quite often a drawing might be a more appropriate way, or a worksheet where they can cut and paste. I've seen students make worksheets where they put a picture of the object into float or sink and talk about why they thought that would occur. That might be another way to get data from our students. And then, yeah, so this is what we're up to now, observe. So can anyone tell me what is something that's happened that you didn't occur? I think Stacey, you were surprised. Did you want to share your observation?
Yeah, I put in a dry sponge
Dry
and I thought
sponge?
it would float.
Yeah.
And once it absorbed the water, it might start slowly sinking.
Yeah.
But it doesn't. It just floats the whole time. It just absorbs the water and then just floats.
So, but when you put it in, did it stay at the top of the water? And then once it
Yep.
absorbed, it might have been just slightly under the water. Would that have occurred?
Yeah, it is. It's slightly under now, yeah.
Yeah. And what would be our explanation? Or Stacey, what would be your explanation for that?
I guess absorbing up all the water makes it a little bit heavier, so it sunk that little bit.
Yeah, okay. That's a nice
Yeah.
observation. What about other people? What were things that happened that you found unexpected?
Yeah, George, with me, I think I just did try with the serviette, like folded in pieces.
Yeah.
So I thought it would float. I just marked it as float, but you know, after just eventually it just started swinging and it just sunk now.
It's sunk to the bottom.
Fold of aluminium foil, the same thing, it happened, but it didn't really sink to the bottom.
Right.
It's just in the bottom, just above the thing. So those are the two things.
Okay. So, so if we came back to our drawing from before, I'm going to get you to do this now. I'm going to get you to do a representation. So if we go with Stacey's example, I'm just going to turn off the share. If we went with Stacey's example, she put a sponge in the water. So, well,
Where is the? Yes, so that should be the rest of the. Yeah.
so we have floating here, and if we have, this is our sponge that Stacey had before. What would indicate our gravity in this case? What would we draw?
An arrow.
An arrow going down like we did before? And how would we show the push of the water that makes it float?
Maybe arrow against this arrow from the bottom to top.
Yep, we can do the arrow in that direction. That could be one way. What would be another way of indicating, because we know that when we put something heavy or something broad and flat on water, it's probably going to float, wouldn't it?
Mhm.
So how might we represent the difference in the way that water is pushing up on it? What's another way we can use arrows in that representation?
Across the surface.
So say that again, Alicia.
Multiple arrows.
Multiple arrows, exactly right. So we could say, because we're trying to indicate here that we're using a broader surface area that will indicate that there's more places that the water can push up on the object. So if I had something like a rolling pin, then if I could figure out how I could magically get it to stay upright, I would have force going down and force going up, but I probably have forces going to the side as the water tried to make it fall in that particular kind of way, wouldn't I? So when we're looking at it, we're looking at the way that the push of the water is pushing on the object and how the shape of the object is affected by the way that the water pushes on it. Does that make sense? So I want you to pick one of the objects that you've got and try and think about how the forces are pushing on this object. I'll just give you a minute to do that. Don't need to show me. I just want you to think about how we can start to visualize the ideas behind floating and sinking to our kids. You're gonna have a sip of water. Can I get one more example of something that was a bit unusual that you weren't expecting?
I had this, can you see, it's like foil,
Yeah.
I don't know, we use it for craft, but
Yeah.
at first it was on the water, but as I left it in there for longer and longer, the weight of the water started to push it down to the bottom.
Right. So do you think that the water got in the air holes?
I think, yeah, they
Yeah.
just started to pull on the top and then pushed it down further.
Excellent. Great. So hopefully we're able to do what's on the next slide here. I need to share screen again. George, what are you doing? You've used Zoom before. There we go. All right. So part of the process is the explanation. So hopefully you are able to come to some sort of explanation about what happened. Can you guys see my screen again?
Mhm.
So it should have explained. You guys have disappeared from my screen. I don't know where you guys are. You're over there. Zoom just randomly picks one of my screens to put you guys on. I don't know where you are. Okay, so it should say explain on the screen. Is that correct?
Mm-hmm.
Yep.
Right, so make sure you provide an explanation. And when we do this with our kids, we want them to give you an explanation, okay? Based on their understanding of the science. You're going to have that one kid that says, well, I think unicorns are keeping it up or magic is keeping it up. But try and push them to give some sort of explanation that's scientifically justifiable, okay? Some kids won't want to do that. Perfectly fine. We're just trying to give them a positive experience in this kind of way. And think about how we could represent their understanding. So arrows could be a good one to tap into those ideas, a range of different things that they could use. And depending on the age of your students, we might want to spend a little time focusing on the words. What does floating mean? What does sinking mean? Looking at where arrows might be pushing up on the object in that kind of, what is a push? What is a pull? These words are very important. And making sure you question your students. I have met students in preppies and early childhood who have told me that when I pulled it, it went that way. Okay, well, what do you think a pull is? Can you push me? And they've pulled me along. So they had the words just around the wrong way. And, you know, you don't want to come down on them, but you want to just make sure you clarify these ideas. And it could be someone else in the group. Maybe Holly, I know, knows what push and pull is. So, Holly, can you show me what you think push and pull are? So that idea as a social group, we're socially constructing our understanding. How can Holly fix the ideas that another student has in that kind of way? All right, we've got one more here. So we've got our lump of plasticine. I'm going to stop the share so you can see me on your screen. Right, I got this plasticine ball here, about the size of, fits in the palm of my hand. Everyone got one in front of them?
Yeah.
Oh, no, nobody do it until I tell you to. Preppies, you gotta wait. All right, so what we're going to do, if I put this on the surface of the water, do we think it's going to float or sink? What do we think? Thumbs up if it's going to float, thumbs down, sink, halfway if you're not sure. No shame in being not sure. All right, so I put it in, 1, 2, 3, sinks like a stone. I even got a splash from that one. All right, I want you to give it a go. What happened? Did bubble come out? Did it splash like mine? Did it hit the ground really quick?
Yep.
How do we go? Did everyone sink? Maybe,
Yeah.
maybe did. Right. So the easy part of the challenge. Your next challenge, you may have done this before. If you've done this before, don't tell anyone. No spoilers. What I want you to do is to try and make it so this, you can shape this plasticine Play-Doh, try and get it to float. What are you going to do? Don't tell me. Give it a go. How are you going to make this float? How can you change this plasticine to make it float? If you know the answer, don't give it away. And people at home, make sure you give it a go. It's a worthwhile activity to do. Give me a thumbs up when you've got it to float. Connie, I think Connie knows how this one works. That's great. Yeah. All right, if you can put it on, if you can put your camera onto it, just show me. I'd like to really see that it's floating. Not that I don't believe you, but I'd like to see what you've done. How did you come up with your solution? Ah, you've got it. Oh, I see what Connie's done. Thank you. Jess, you had your thumbs up before. Do you want to show me? Can you show me if it's easy? Okay, Jordan, she's got a jug. Oh, she's thinking ahead. Yeah, okay. All right, so people, tell me, what did you do? How did you make it float? Connie, you're the one ahead of the game. What'd you do?
Take it into like a little bowl.
Make it into a bowl or a boat is the word
boat,
we're
yeah.
trying to think of. Because when we do this, whenever I do this with students in the room, did anyone try the first one, which is just to make it flat? Did anyone try that one?
Yeah,
Everyone-
I did it flat.
Yeah. And when you put it flat, what happened, Holly? Did
It just sunk.
it just sunk. Yeah, that's basically
Mine's all
because
gross now.
yeah, water got on top of it. And once the water gets on top, it's just going to go down. And that's the thing you're going to get your kids to do. So, of course, we need to make it into a little bowl or a boat shape like that. If you've not managed to do it, give it another go now. Sometimes it works, sometimes it doesn't. And that's fine. That's a fun thing we can do with our kids and ask them, well, why didn't it work? Oh, because you got to make it. Yeah, see, I'm not making it work now. So I'm just an embarrassment to my industry at this point. But you know, you got to have a go. And, you know, even if your kid's seeing you wrong or it's not easy, that's great to show them that we're doing something that's not so easy today. So if you don't get it right the first time, that's fine. And that's what scientists do. It becomes a lesson in that kind of way. So did everyone get it in the end? Right. So now what I want you to do, we're going back to our drawing again. I want you to draw two pictures for me. We got our drawing here. I'm pretty sure people can see what I'm about to do. So we have our water again in that kind of way. We've got our object when we just make it flat. When we have our Play-Doh when we started. And then we're going to have our object when we make it into a boat shape like that. Okay. Everyone see what I've done? Mm-hmm. So now I'm going to get you to figure out where the arrows go. How are you going to draw the two forces? So one, obviously where the object sank, and one where, because it's in the shape of a boat, it didn't sink. Where would you put your forces? All right, I'll give you a minute to do that. And then I'm just going to get someone to tell me what they did. Don't have to show me. I trust you. All right, give me a thumbs up if you've done the drawings. Jordan, can you tell me what you do? What did you draw?
So I drew an arrow on each side where it was curved, like pointing up where the air was. And then I did an arrow going down into the bowl and an arrow going down under the bowl where it was like at the bottom.
All right.
Yeah. Like
Oh, you got blur on.
oh yeah, sorry.
That's okay. That's all right. That's why I didn't ask everyone to show me the pictures. Okay. Anyone else want to share what they did to tell me? Anyone else? Alicia?
Yeah, I just did, so with the flat, it had more points of gravity
Yep.
pulling it down, and then with the bowl, it just had one singular arrow of gravity of where the curve is.
Right. So in this case, I'd probably go with the down arrow with the flat object because it just sank, didn't it?
Mm.
Wasn't enough push of water to keep it going.
Yeah.
But we have the same gravity. So when you talk to your kids, we're literally using the same weight, aren't we? It's the same piece of plasticine. It is literally the same weight. And if you wanted to, you could put it on scales if you wanted to do that. But in this case, because we stretched it out, we changed the way that the force of the water is pushing up on the object. So in this case, we can go with an arrow down because it sinks. But in this case, we need to have an arrow going the opposite direction to show the push of the water. So in this case, I would draw, if it was me, and it is me right now, I would draw a couple arrows pushing up from different positions on the actual boat object. Can people see what I mean?
Yeah, that kind of is what I did. I just didn't explain it very good.
Yeah, no, that's fine. That's perfectly fine. And that's why when we explain, we've got a picture, we have another opportunity to explain. All right. Just like I said, if a child comes up to you and says, well, I pushed him. It's like, really? Can you show me what push means? You've got another opportunity because they know the words, but the action itself will give you more insight into what they're saying than just the words itself. So we need to give our students a number of opportunities. Oh, I just don't need to spill this in my office. Oh. We need to give them a number of opportunities to explain what they're thinking, to get insight into their ideas. And sometimes they're going to be contradictory. Okay, and that's perfectly fine. We're working out our ideas and our thinking about these things. Okay, so we're done with the floating and sinking for the moment. So if you want to pop it away, because I know having water near our laptops is never a good idea. So make sure you safely put it aside. Okay, how are we going for time? Not going badly. All right, so I'm going to share my screen again. So these are some of the activities you can do with your kids. As you could imagine, in that first session, in that first part, we did a whole bunch of floating and sinking of different objects. And when you do this, make sure you pick a range of different objects ahead of time. Because I know when teachers do this for the first time, they quite often go, hey, we're going to do floating and sinking today. So Alicia, I want you and everyone in the class to grab an object from around the class. And that's good because that gives students to participate in the objects, and they can be a bit more excited because they know they're going to put these things in water. But the downside is that you could have 5 students that all pick something that's made of plastic. And we all know how much plastic is in an early childhood center, right? And then you're going to have an experiment where everything floats, and that's going to suck for you in terms of your data collection. So when you do this, you can get them to get a whole bunch of different things, but because you're a good planner, you're going to bring in a whole bunch of things that might float and might sink. Maybe you're going to have coins, maybe you're going to have a plastic ball, you're going to have candles, you're going to have a whole bunch of different things. So you just add them to what the students have got, just to make sure that they can see things that float, things that sink, things that are going to float in a weird way, and that kind of thing. Because as you know, from what we just did, it's the ones that were like, wow, that's a bit weird. I wasn't expecting that, are the ones that are going to be the most interesting and are going to give you the most information for your assessment tasks, or when you teach this in general. All right. While I do focus on assessment tasks, this is what I want you to do in the classroom this year, next year, and for the rest of your careers. Okay. Really important. Can people see challenge on the screen there? Yes. All right. So we did floating and sinking, and that was great. We did drawings of our representations, getting students to do drawings. They love doing that. And then I want you to, when you do assess the assessment tasks, particularly number 2, you're going to have to do a task, and it's always good to have an extra task that you can quickly add on. So you saw I had floating and sinking, but then with a ball of plasticine, I had a whole new experiment, didn't I? A whole new activity I can do with my kids. So make sure, and the main reason is because in assessment 2, we're doing probing. We need to understand what our children already know. And if you do a floating and sinking task and you find out, let's pick somebody, Nobuko. Sorry if I'm getting the pronunciation wrong. Nobuko, if Nobuko does it, and she knows everything about floating and sinking, she got this 10 out of 10 right. It's just like, oh, okay. And it's 5 minutes and I didn't really collect much data, but she may not know the plasticine boat task. I bring that with me. I've got a whole new task and a whole new bit of data that I can collect when I'm working with my kids. So it's your job to make sure you plan for things. Maybe you have 2 tasks, but you only do one of them if things go really well. And if things are going a bit pear-shaped, I've got another task that I can do. Just means I can collect more data for my assessment tasks. Okay. Right. So the next part is a number of different ways that we can add on. These are different ways that we can modify the floating and sinking tasks. So a basketball in a bin of water. So you might have a tub like we had before, and putting a tennis ball or a basketball. So when students do it, they can have that, they can push on it and they can feel the upthrust of the water. So part of that is experiential learning. So, a lot of the time we show videos, but the students miss out on having a hands-on experience in that way. So having hands-on experiences is really what I want to emphasize in this unit, not just showing them YouTube videos. Okay. We can do a house brick in a bin of water. What's a house brick going to do? Karen, what do you think a house brick in a tub of water is going to do? Is it going to float or sink? Oh, you got your mic off?
There we go. Sorry, I've never done Zoom before, so still learning.
So is it going to float or sink, do you think?
It's going to sink.
Right, but what else is going to happen to the water in that tub?
well, the water's probably going to come out the holes too,
Yeah, so we
come
push it
through the
in,
holes.
and that's going to displace the water by pushing it up a bit, isn't it? And kids will have that experience. We've all been in the bath, and I'm sure they've had that experience. Maybe you've been in the bath and think, wow, Dad, you really pushed the water up a lot, and I'm a little bigger than you. So that's going to happen. An Archimedes diver is something worthwhile. An Archimedes diver is, you may have seen it, it's like a little guy in a bottle of water. And what happens is, when we generally do it, you squeeze the bottle, and what do you think is going to happen to the diver? Is it going to go up or down? So it could be one of the little army dudes. If I squeeze it, if something's in water and I squeeze it, does it go up or down?
Does it depend on where you squeeze it and where the diver is?
Nope, doesn't matter where I squeeze it. Could be at the bottom, could be at the top. What do you think is going to happen? So
Up.
our general
go up,
intuition
up.
will be that it goes up, doesn't it?
Yeah.
But what happens with this, it's got a little air bubble inside it. And when we squeeze it, we squeeze that air bubble, which makes it a little bit heavier and pushes it down in that way. And it's a nice way. And if you have a look online and look for Archimedes diver, you could make one at home with like an eyedropper that you put medicine on, and you put a little some blue tack on it, and it will change the way it goes. It's something you could do if it's something you wanted to do. It's a hands-on activity worthwhile having a look at. Right. So hopefully you got something out of today's session. We've covered a number of different ideas that we're going to go over with floating and sinking, and it could be something you do for your assessment task too. Okay. Now I'm going to click on the next one. And so what we're doing in this unit is we're also looking at teachable moments. Who can tell me what a teachable moment is? Who's going to be brave enough to put their microphone on? What's a teachable moment? You probably already talked about these in your other units.
A moment where you can see that the child is interested in something, so you use like something that you know to help increase that knowledge.
Exactly right. So what we're doing is we're doing a number of different types of instruction in this unit. So what we're doing right now is called direct instruction, where I'm literally telling you what we're doing. PowerPoint slides, a blackboard, it's called direct instruction. And then before, what we were doing was guided learning. So I was taking you through experiences that I know will help you, scaffold you, and I was guiding you through how to do them, and you were doing them on your own. And guided instruction is really good because students have agency about how they're doing it, how they're responding to it. It's hands-on. And the teachable moment is that opportunity, like Jordan said, to extend our students' understanding a little bit more, to get them to answer their own questions, to get them to think. So, because there's nothing worse when we're a young student, primary, early childhood, if I just come in and I tell you what the answer is.
Whoa, is he frozen? George,
Frozen.
I think you're frozen.
I think so too.
Uh-oh.
Oh no.
He's just really good at playing freeze.
George, you're frozen. I'll put it in the chat. Uh-oh.
He wants
How
to
do you
know what
write
we'll
to each
do.
other? How do you write to each other?
In the chat. If you click down the bottom and says chat, then
Oh, okay.
yeah.
Thank you. Thank you.
No worries. Oh, where did he go?
I've just got Holly in my big screen.
Oh, my sunburned face. Oh, he must have dropped out.
Pop it back in again. Oh, here he is.
It's Alicia. I can see Alicia.
It's back.
Hello.
Someone's back.
Mm.
Oh, Holly's back.
George, where'd you go?
Lordy, lordy.
You're
Here.
frozen.
Can you see me?
I can
We
hear
can't see
you.
you. We can hear you now.
Okay. So nothing like coming into the university because you think the internet can be better than at home. Okay. Am I moving now? You guys can see me?
No.
No.
You're still
No.
frozen, but we can hear you.
Okay. All right. That's embarrassing. Okay. All right. Let's try again. Sorry about that, guys.
It's all right.
Was not part of what I had planned. Hey, let's just collapse and ruin my presentation.
Oh, there we go.
Okay, we're good. You can see teachable moments again.
Yeah, we can see
Yes.
that.
Okay, we're recording. We are recording again. Excellent. All right. So as I was talking, so the teacher told that little girl, why don't you try and find out what happens when you get to, you're on the screen over there for some reason. Thank you very much. What happens if you, can you still see my PowerPoint?
Yeah.
No. Yep.
So the idea of what happens if you try it from different positions. So she had a whole team of other early childhood kids, 4 or 5, and they went around the yard pouring water in different locations. And she came back to the teacher about half an hour later, giving the answer, saying, well, when I pour it, they all go to this position because it's the lowest point in the playground. So that was a great teachable moment where the students were able to answer the questions for themselves. They were engaged and they answered the question. You get a bit of, you know, a push when you can answer your own questions. And that's what we're trying to promote in this unit as we go through. Okay. So now what I'm going to do is this next section here is what is a concept? Now, this is one of the most important things that you need to know for this unit to have a good understanding of what a science concept is. So on the screen there, you guys can see that. Yes. Just checking what a concept is. Right. So a concept is a key idea or a short statement of understanding. It is not simply a fact or a word. So when we're talking about science concepts, I want you to think about a statement. So on the screen there, we have a fact. A coin will sink. We had, you know, if you tried a coin today, you probably found that out, but that's a fact. The fact that Mount Everest is the tallest mountain in the world is a fact. But it doesn't mean I can draw a whole lesson out of this, okay? I'm trying to teach my students concepts that will further their understanding of something. A coin will sink is a fact, but science concept behind it is that objects float if they are light for their size and sink if they are heavy for their size, okay? So hopefully you were able to see that science concept in what we did today with floating and sinking. And for your assignment, I want you to think in terms of science concept. So science concept is a broad science concept that offers opportunity for investigation of overarching ideas and the ability to explore the interrelationship between the ideas. So when I do things like putting a coin in water and I compare that to putting, you know, a ping pong ball in water, I can start to explore the differences between these things and how the push of water and the pull of gravity are affecting these things in different kind of ways. You could easily do a lesson about floating and sinking in that kind of way. And it's really important in these assessment tasks that you get a science concept right. And I'm going to show you where to find them in this unit. So another thing is these are the titles. Sorry, I'm just changing something. These are descriptors. So we have a whole area of physics. Physics is massive. It's about space, it's about nanotechnology, it's about gravity, it's about light, way too big. If you came to me and said, hey, George, I did a lesson on physics, even if it was early childhood or university, there would be so much to cover, you couldn't do it effectively. We could focus on space, an aspect of physics. So planets, eclipses, phases of the moon, still a whole bunch of areas. But one of the things that we could do is focus on these science concepts. So one, the Earth is the shape of a ball. And I'm pretty sure you could come up with a lesson or find a lesson plan that somebody else has written about the Earth is the shape of a ball. It could be about gravity. It could be about eclipses. It could be about the shape of all the planets in the solar system. Okay. So you can see it as like a learning intention. It has to be quite broad. Having just a fact isn't going to teach our kids anything. Second one, stars are still there during the daylight. You could easily have a look at that. Maybe look at the beginning of the day, end of day. We can start to see the stars and the exploration of those kind of things. Science concept 3, the planets in the solar system differ in size. You could come up with an activity for that, couldn't you? We could name the planets. We could look at the different sizes, how far apart they are, that the first 4 are made of rock, that the last 4 are made of gases. Really easy to come up with activities about that are interesting and easy to explore. Okay. For biology, again, biology is a massive area. Animals, still a pretty big area, but our science concepts could be each type of animal has its own life cycle. Pretty sure you could easily come up with an activity about that. We're reading Very Hungry Caterpillar, looking at the life cycle of a wombat, life cycle of kangaroos. These are things that we could explore with our kids through a story or a song, those kind of things. Many animals have skeletons. Right? We have skeletons. It's called an endoskeleton. We have our skeleton on the inside of our bodies. Some animals, like scorpions, have an exoskeleton. So the skeleton is on the outside of their bodies, and that changes what they're able to do, how strong they are. And we can explore that with our kids. So in your assessment tasks in this unit, I need you to know what the science concept is in the activity you are going to teach. If you come through and say, I did biology with my students, bow, you're going to lose some marks. Okay, that is not a science concept. It is not the topic. It is not the name of the activity. Hey, George, we're going to do life cycle of wombats. That is not a science concept. That is a title. Okay, I'm going to show you where you can find them in a minute. Now, the other thing, if you haven't had a chance to look at the lecture, is the idea of alternate concepts. So everyone knows what a misconcept is. When we have a misconception about something. A misconcept is when you get the wrong end of the stick about something you're taught at school and those kind of things. But in early childhood, we deal with what are called everyday concepts or alternate concepts. And an alternate concept is an idea students develop on their own before they've been formally taught something. And I always give this example. If I've got my 1-year-old, my son is Javier, like Javier Bardem. He is now 7, but when he was 1, he would sit there on his high chair and just drop things from the side of it. I'm sure we've all had that experience before. And he's just dropping them to see what happens. He drops another thing, surprised every now and then when something breaks and dad gets really upset, but he just dropped them off the side. And if one day I give him a whole bunch of green things, he's going to drop them and have a look. And my son's going to come to the conclusion that all green things fall to the ground at the same speed. He's not wrong, is he? Green things will all fall to the ground at the same speed, but that's only because all things fall to the ground at the same speed, unless they're paper or something like that, and air is pushing up and cover that in air and flight. So an alternate concept is something that's not quite correct. So in your assessment, if you come to me and say that all things that are light will float and all things that are heavy will sink, that's an alternate concept, not quite correct. And we can challenge that because if you have a paperclip made of metal, paperclip made of metal is light, but it's heavy for its size. When we put it in the water, it's going to plunk and hit the ground. The other example would be that container ships weigh millions of tons, hundreds of thousands of tons of weight, but they're able to float on the water. So it's not as simple as saying that light things float and heavy things sink. That's an alternate concept. And you need to be able to identify them in your assessment tasks for this unit. Okay, really important. Right, so the science concepts we covered in this unit are these ones. That some objects will float depending on the material it's made of, not its weight. And you guys did that. Did you get things that are made of wood that generally floated? Was that right? Things that are made of plastic will generally float. Things that are made of metal will generally sink, or rock, or glass, or those kinds of things. And when you do that with your kids, you can ask them, well, we put in one tub all the things that floated, and another tub all the things that sank, and one another tub for the things that were kind of in between. We can do that, and we can make a generalization. What can you notice about all the things that floated? Well, they're all kind of plastic. Well, they're all kind of light for their size. That's some of the categorizations our students can make. Okay. Second point, objects float if they are light for their size and sink if they are heavy for their size. Covered that one. Point 3, an object can be light for its size if it contains air, such as a hollow ball. We did that one, maybe use some balls in your process. Materials with a boat shape will float because they effectively contain air. And again, that's what we did with our plasticine. And that water pushes up on objects with an upthrust force. So we covered all of these things today in our activities, didn't we? Okay, so you've got some exposure to the science concepts that are related there. So make sure you get that right. Okay, and there are our slides for this unit. Okay, now, as I said before, I'm going to give you a bit of a tour of the website. So I'm going to stop the share there. And what can I do? Okay. All right, now I'm going to share the screen. I'm going to take you for a little bit of a tour. Go on. All right, can you guys see the website there? The Cloud Deacon website? Yes? Getting some nods? Okay. All right, so this is the Cloud Deacon website. This is your view. So I'm going to take you on a quick tour. Hopefully, so if we go to content here, you will see that this is kind of what you should see. We click on Zoom links. That's how you guys got here today. And so I'm pretty sure you know where that is. We have the teaching schedule. So I want you to have a look at that when you have the chance. This is what we're going to cover every week. The chapters that I want you to read from the textbook, those kinds of things. Okay, make sure you have a look at that one. We have our unit guide information, or that was the page we were on. We have our assessment tasks. So far, assessments 1 and 2 are open, but the main one that I want you to have a look at is this one here. It's a 2024 description and requirements of the assessment tasks. This is all the information for all the tasks that you need. So I want you to read this before you come to me and say, hey, George, what's 1A about? Read this document first, okay? We're going to go through this in a minute. I'll come back to this. And then under the assessment, assessments 1 and 2 at the moment, and they will have more information about things like templates, rubrics, and that kind of thing. Okay, so make sure you have a bit of an explore. We go down here to our readings. Now, this is the most important thing, these two. If you're going to remember anything from today's presentation, this is what I want you to see. Here is our link to our textbook, okay? All right, so we go through, it will load to the library. Hopefully I won't have to sign on. Excellent. So this is, can people see this? I can see a textbook there, link to the library. Excellent. All you need to do is click on this button here that says read online. Okay. I think Stacey's following along. She's on the website, I think maybe. Yeah. You go to read online, click there. We'll get this pop up here. You do not need to log in. You do not need to register. You do not need to send credit card details or anything like that. All you need to do is click on this button here that says continue with read-only access. Everyone following me there? If I click on that, that will take us to the textbook. Whenever we're ready, and there we go. We have the textbook there. If you want, this button here will show us a table of contents. We click here, and we go to chapter 1. Okay, that's how you access the textbook. Okay, for people watching at home, I'm going to put this online because I know some people are having a little difficulty finding it. Okay, easy peasy. Going to move on. Second thing that you need, and if you forget, these are the instructions that I just followed here. Okay, in case you forget, but you don't want to go through this whole video again to get to that one thing. Second thing I need you to do, well, there's 3. This one here, the Ideas Peter 8 book is a PDF document. It's going to have every single activity we do in this unit. Okay. It's a PDF. I suggest you download it and put it in a Dropbox or a USB, because I know, Holly, in 10 years, when you're told, Holly, so-and-so is sick, you're running the science units today. You're like, and you can come back to this and look at, oh, what the hell did George talk about 10 years ago? This is the doc you can refer to, okay? Now, resources for teaching science. This is the same as the PDF I just showed you, but this is in the form of a blog, which you might want to have a look at. It has all the activities that we are doing. So in this case, we would go to floating and sinking here. You can see we've got a whole bunch of different ones. Floating and sinking is what we covered today. These are the science concepts for floating and sinking. Is that big enough for people to see? Is that okay? These are the science concepts. When you're submitting your assessment tasks and I ask you for a science concept, if you are doing floating and sinking, I would expect to see one of these. Okay? So make sure you have a good understanding of what your science concept is for your assessment tasks. Okay? We'll also have things like alternate concepts. There's already been research done on what alternate concepts we can expect from early childhood students. Make sure you're aware of what alternate concepts your students will have. And then at the bottom here is the PDF, which will take you again through to the activities related to these science ideas, science concepts. Okay. So if we just want to go back a step. So for air and flight, we click through. Air and flight have a whole bunch of different activities. Air is all around us. Wind is moving air. It fills up spaces if allowed. So make sure when you're going through part 1B, you have a good idea of what the science concepts are. Okay. Excellent. So moving on. Okay, Katie, you need to email me about your topic. I'm not sure how to get children. We can talk about that. Right. What else do we have? We have online classroom and not having a good. I do teach technology, which is the irony, and I'm just having all these issues. So we have lecture 1, the recordings there, and the slides. So you can watch me talking away. You may learn a lot. I may put you to sleep. It's up to you. And then we have, this is 1B. So after the presentation today, This will take you to 1B, the pre-recorded session I did about air and flight. It's from a previous year. So you get to see me looking a little younger with less wrinkles on me. Okay. I also did 1A if you want to go over what I did a couple of years ago, but it's exactly the same as what you're doing now. Okay. Yeah. What else? We have our discussion space here. This is where you are going to put your questions about the unit. I have for you guys, cloud students, this is where you put your questions about assessment 1, 1B, 1A, 1B, A2, A3. Again, I don't need 300 versions of the same question. Do you have a question? Pop it in here first. Myself or Taylor will get back to you ASAP. And then I also ask you guys to answer these questions. Each week I'll have a different one. Describe how science has impacted your life and how you can incorporate science into your practice. This gets a bit of reflection going, a bit of discussion. It's quite always hard when you're studying. It's not back in the day when I studied, it was all face-to-face. But now you guys are online. It's really good to build a community. People you know, maybe live in the same area, always a positive thing. Okay, that's our discussion space. Finally, when it comes time to submit, this is where you submit your assessment tasks. Okay, when I click on portfolio activities, I'll get menus that ask you for a Word doc, PDF, that kind of thing. That's where you upload the information and it has our due dates there. Okay. Then the other most important thing is the extension request. If something happens to you, generally extensions are given for things that are unexpected. If you are going on a cruise to Hawaii, you're probably not going to get an extension. But if you, like me, had, a tree damage your house when we had the big storm a couple of weeks ago, that's worthwhile of an extension. We have, parents who get sick, kids who get sick. I got COVID a few weeks ago. So, there are reasons that come up. You'll need evidence, maybe a doctor's certificate, maybe a stat deck. If you are someone who has communicated with a disability resource center, have an LAP, you'll need to let me know that because there are different rules for people who have LAPs. So make sure that you let me know that you have one before as you submit for the extension. Okay, I can give you a maximum of 1 week extension. If you need longer than that, it becomes a special consideration issue. Okay. All right, really important. All right, everyone okay with my brief tour? It all made sense?
George, I have a question because I was looking at the unit and I noticed it's with every unit, but the content progress, are we expected to look at everything on the content progress? Like with this unit, we've got 57, and so every single thing that you look at, it's like a progress, but a lot of the things on each unit, like the Turnitin, are the same. So do you actually look at whether we look at the content progress?
I'll look at it if you're struggling. If you come to me, you don't know anything and you've not looked at a single thing on my unit, my response will be different than if you looked at everything and you still don't know what to do. But I don't look at my progress in your progress in terms of your submissions or anything like that. Okay. You get marked on your assessment tasks. That's what you get marked on. Okay.
Yeah.
If I haven't answered your question, please send me an email. I'm not 100% sure if that's what you're asking. Okay. All right. We're going to continue on. Don't have much time, so I'm not going to take any more questions at this time. Right. What I want to do is take you through the first assessment task 1, which has got 2 parts, part 1A and part B. So we go to assessment. We go to the assessment document here. Okay. For assessment 1A, you are going to be doing a task from astronomy. Astronomy is what we cover next week. So in astronomy, you're going to pick a science concept, like the Earth is in the shape of a ball. You are going to pick an activity from that web page that I showed you before. We're going to go through it next week, so you'll see some examples. And you're going to do an activity with kids, okay? Can be early childhood age, could be primary age. The emphasis of this assessment task is for you to get practice doing it with kids, all right? So we're going to do space because it's probably something you've not done before. It's a bit of a challenge, okay? And the beauty of this assessment, it's only worth 10%. So if you screw it up, it's not the end of the world. And in anything in education, you'll find that as long as you can learn something from your experience, that's great. That's what I'm looking for. You don't run it perfectly, that's fine, okay? So you need to have a science concept and activity. You're going to do the activity with at least 2 children, not just 1 kid, okay? and you're going to run it, and you're going to think about how I'm going to collect evidence about what they learn. Because we know as educators, I could have the best lesson in the world. I sold my soul to the devil for this lesson and I taught it. And it doesn't mean that my students learned anything. Okay, they might have had a bad day, had a fight in the playground, their best friend's sick today, whatever reason. But we need to know for our job, for our bosses, for our parents, that how do we know that Tess learned anything from what I was just teaching? Okay, so I would need worksheets. I would need drawings of what they did. I would need quotes of what they said in the lesson. So that's the main emphasis. You're going to run a lesson. You're going to collect some data that will let me know how you know they learned something. I know they learned something because when I got them to draw the day and night, they drew half of the earth in daylight, half of the earth at nighttime. That's evidence, okay? When I gestured, they indicated something that's relevant. You need a couple of bits of evidence that will indicate that you know they learned something because, okay? A big part of this unit is collecting data and knowing how to analyze that data.
George, sorry, George, are you happy to have videos as well or photos?
No. You can have photos. I don't want to see any children's faces in the photos.
Yeah.
Don't want video, don't want audio recording. Okay.
Okay. Yep.
All right. Any modifications you might make next time, you do the activity related to what you just did. So if I gave Jordan the lesson and Jordan knew everything about space on this task, knew everything about day and night, what would I do next for Jordan? I know Jordan knows everything about this topic, so I would pick a more sophisticated concept, a new science concept, and this lesson because Jordan knew everything about it. If I taught Holly, I'm not saying this about you, Holly, but if Holly didn't understand anything, she didn't know what day was, she didn't know what night was, and didn't know anything, what would I do? I might do the same lesson again. I might modify a little bit so that I know that next time Holly will get something from the lesson that I planned. Okay, so I need to link it to what happened and what they did or did not learn. Does that make sense, people? It's pretty easy. It's 400 words. And so what you are submitting, I'll go back here, is you are submitting two things for 1A. You are submitting a 400-word report. Okay, now a report is it's not an essay, it's not a novel. A report reports on data that you've collected. Okay, I put some information in the unit guide folder as to what a report is. If you click down to assessment tasks, there is what is a report. That will help you if you don't know what a report is. Okay, so you're going to submit a 400-word report on what you did, what your student learned, how you know what you're going to do next time. And alongside that, I have put together, if I go to assessment 1, I have put a template together. You guys can see that? So if you're someone who hasn't had much experience yet putting together a lesson plan, I would fill this out with as much detail as you can provide. Okay, don't kill yourself. I don't want 20 pages of template. Page is perfectly fine. Okay, and you can submit this alongside your report. This doesn't add to the word count. Okay, this is just because I know I'm just going to pick someone. Karen hasn't done one before. I can see she did all the planning, but she didn't put important bits in the assignment. I can give Karen a couple of bonus marks because I can see it in the template, just didn't put it in the report. Okay, if you're super confident, like Stacy is, if you're super confident, George, I don't need no template, that's fine. Don't do one. I don't need to see it. Okay, it's up to you. No marks attached to it. All right, everyone understand that one? Okay, I will go over these things again next week as well. All right, I'm going to just go to 1B, or just running over time. We go back to the assessment requirements. 1B is a super easy task. I'm always sad that I'm giving this as an assessment task because it's so simple. All you've got to do, 1B, is you literally just got to read chapters 1, 2, 4, and 5 from the textbook. These are the ones I would hope you would read anyway, because they're really important. It's a good foundation for this unit. Just got to read those 4 chapters, and then you are going to provide a response of 100 words for each chapter. In that response, you are going to provide a brief summary of the main ideas in the reading. And this is just dot point. I don't need to see prose. It was the best of times. It was the worst of times, George. Don't need that. Just dot point the main ideas from each of those chapters. And then I want you to write a short reflection, a couple of sentences about one of the ideas from each chapter and how you're going to use that in teaching. Okay, it could be on how to use questioning, how to use play-based learning. All these kinds of things could be done. Okay, And that's it. I've even provided you with a template. 1B. All you have to do is fill in the template. Chapter 1, my dot points, my reflection, my dot points, my reflection, dot points, reflection, that kind of thing. That's all you got to do. You just submit that template and that's it. 1B in the bag. Okay. 10% of your mark. It's going to help you with your assignments no end, I guarantee. Okay. Right. Now, I'm not going to talk about assessment 2 in much detail. All I want you to do between now and next week is go through the assessment document, read about assessment 2. It's a bit more complicated, but we're going to talk about that next week. Okay. All I want you to do. So for assessment 1A, you are finding at least 2 children that you can work with. They can be early childhood, between 3 and 8 years old. So if you're in primary, that's fine. If you're having difficulties, let me know in the discussion forum about you're having difficulty finding kids that young. You need to have at least 2 because we're looking at social constructivism, how these 2 students work together to help you. For assessment 2, we are doing something similar. So assessment 1A is about you practicing how to do an experiment with your kids. Okay. Assessment 2 is looking at what they already know. It's what's called a diagnostic assessment. So whenever we're teaching, we need to know what our students know at the beginning of the sequence. Basically, because if I come in and I'll pick on somebody else, Andrea, I've never met Andrea before, and I need to know how much Andrea knows so I can pitch the lesson at the right level. If it's too hard, she's going to get bored. If it's too easy, she's also going to get bored. So we need to pitch our lesson at the right level. So assessment 2 is a probing lesson where we try and figure out what our students already know. And it's 2 parts. Lesson 1, learning what they know. Lesson 2 is teaching them something new, whether it's strengthening a concept they don't know or extending them because they knew everything about it. Okay. So for that assessment, you need to find 2 children you don't know. Okay. Assessment 1, you can do it with your kids, with your cousins, with your nieces, nephews. That's fine. Assessment 2, you have to find 2 kids you don't know. So this could be friends of the family. It could be if you're working in an early childhood center, you could use the kids at the early childhood center. You need to get permission from leadership to do that. If you're using family friends, you need to get written permission from parents saying that they're happy for you to do stuff, you know, sciencey stuff with their kids. Okay, really important. Yeah, I'll leave it there for now. So I've just thrown a lot of information at you. No one's burst into tears this year, which is a good one for me. That's great. So what I'm going to do is I'm going to stop sharing that screen. I'm just going to show you a little bit about what I want you to think about for part 1B when you go through the lecture. Go through the seminar task. Module 1. All right, it's gonna take a couple of minutes. I know we're running a little over time here. All right, so this is, can you guys see that slide there? You guys have gone over there again. Don't know why it puts you over there. All right, so seminar 1B, I want you to think about it's air and flight. It has to do with forces, just like with water. But again, we're looking at gravity, we're looking at pull of gravity and the push of air in this particular one. We start to look at what an inquiry is. We go through predict, observe, explain in a bit more detail. So make sure you have a look at that. And this is an interesting task that you can do with kids. So just like today, when we went through the floating and sinking task with children, this is one you could do with your kids about where is the air in this image. All right, I'm going to pick on someone right now. Karen, where do you think air, Karen, I want you to channel your inner early childhood student. And where would they say air is in this room? Where do you think?
I'd probably say around the window.
Why? Why around the windows?
Might come inside.
Might come inside. Excellent. What else? Tess, what else might an early childhood student say? Where's the air in this room?
Probably in the sky, near the ceiling, up
In
high.
the sky, near the ceiling. Okay. Holly, what about you? What do you think an early childhood student would say?
Everywhere.
Everywhere. Connie, what about you? What would an early childhood student say, do we think?
I agree, all around the room. Yes.
Right. So that's, I think that as an adult, we might think that, but I think as an early childhood student, students are often going to say, I know air's over there because I can see the trees move. Quite often students will confuse the idea of wind is the same thing as air. And so with this one here, we have an activity where we could get our students to explore those ideas. Okay, so I'm going to pick on someone, Julie. There's number 4 is the fishbowl. How do I know there's air in the fishbowl?
Can we breathe in the fishbowl?
Right. There's a fish in the fishbowl. The fish is not dead. I know that living things need air to breathe. So I know there's air in there. And we could say number 10, in a closed cupboard. I could have a student say, there's no air in the closed cupboard because it's closed. So, oh, okay. So Stacey, if I got you to go inside the cupboard and I closed it, would you die? Because there's no air in there. And they go, no, I'd be fine. Well, does that mean there's no air in there? No, there has to be air in there because, as Julie said before, we need air to breathe, don't we? So if I go in there, there's going to be a little bit of air. We might not want to stay in there for very long, but there's air in there. So we could use this as a starting point in that way. And in an early childhood context, one of the activities I get you guys to do is to get a plastic bag. And then I say, all right, everyone, I want you to go and capture some air from the room. So you get a whole bunch of early childhood kids running around with bags, scooping it up and holding it nice and tight. I've got air. How do you know you got? I can feel it on the inside. Okay, so why did you go under the table? Because I knew there'd be air there because. I went outside because. We want them to tell us what they think about air. And, you know, linking it to things like living things. That gives us a good idea, you know, about what living things are, what living things require, and those kind of things, which is a whole other conversation we can get started with. So that's a teachable moment right there that we can move on to. Okay. So I'm going to stop it there because we're running out of time. I always like to stick to time. I'm going to stop the recording.